Good morning to all people around the world. My name is Luis Ferdinand, and I'm from the University of Mercu Buana. Today, I'm going to answer some questions about computer organization and architecture that given by my lecturer from the university. The first question is going to be, what in general terms is the distinction between computer organization and computer architecture? First, we're going to define what is computer architecture and computer organization. Computer architecture refers to those attributes of a system visible to a programmer, or those attributes that have a direct impact on the logical execution of a program. Examples of architectural attributes are instruction set, the number of bits used to represent various data types, for example, numbers and characters, input-output mechanism, and techniques for addressing memory. The second one, we're going to define what is computer organization. Computer organization refers to the operational units and their interconnection that realize the architectural specification. Organizational attributes includes those hardware details transferred to the programmer, such as control signals, interface between the computers and peripherals, and the memory technology used. In general ways, the difference is computer architecture has a visible attributes to the programmer, yet the computer organization attributes are transferred to the programmer. The second question is, what in general terms is the distinction between computer structure and computer function? Computer structure is the way in which the components are interrelated. The function in the other way are the operation of each individual component as part of the structure. To make it more easy to understand, the difference is structure is how each component related and be functional to each other. In the other hand, function is how a component work individually and can be used for. The third question will be, what are the four main functions of a computer? The main function is data processing, data storage, data movement, and control. Data processing are data may take a wide variety of forms, and the range of processing requirement is broad. However, we shall see that there are only a few fundamental methods or types of data processing. Data storage. Even in the computer is processing data on the fly, which means data comes in and get processed, and the result go out immediately. The computer must temporarily store at least those pieces of data that are being worked on at any given moment. Thus, there is at least a short-term data storage function. Equally important, the computer performs as a long-term data storage function. Files of data are stored on the computer for subsequent retrieval and update. Data movement. The computer's operating environment consists of devices that are served either source or destination of data. When data are received from a deliverer to a device that directly connected to the computer, the process is known as input-output, or we write it down I/O, and the device is referred to a peripheral. When data are moved over longer distance to or from a remote device, the process is known as data communications. The fourth one is control. Within the computer, a control unit manages the computer's resources and orchestrates the performance of its functional parts in response to instructions. Question number 4. List and briefly define the main structural component of a computer. Computer here have 4 main structure. The first one is Central Processing Unit, or the CPU, often refers to as processor, which is control the operational of the computers and perform its data processing function. Main memory, which is to store data. Input-output, move data between the computer and its external environment. And the fourth one is system interconnection, some mechanism that provides for communication among CPU, main memory, and I/O. A common example of system interconnection by means of a system bus, consisting of a number conducting wires to which are of the other component attached. The question number 5 will be list and briefly define the main structure of component of a processor or of the CPU. The control units control the operation of CPU and hence the computer. Arithmetic and logic unit, or we sometimes call it ALU, performs the computer's data processing function. Registers provide storage internal to the CPU. CPU interconnections, some mechanism that provides for communication among the control units, ALU, and register. What is stored program computer? A stored program computer is a computer that stores programs in memory which are accessed electronically or optically. A fundamental design approach first implemented in the IAS computer is known as the stored computer programs concepts. Question number 7. Explain Moore's law. Initially, only a few gates of memory cells that can be produced and packed together. Over time, it becomes possible to pack more and more components on the same chip. This destiny growth is one of the most extraordinary technological trends ever recorded. This figure reflects to Moore's famous law, which was propagated by Gordon Moore, founder of Intel, in 1965. Moore's law stated that the numbers of transistors of microchip doubled about every 2 years, though the cost of computers is halved. The pace slowed to a doubling every 18 months in 1970s, but has sustained that the rate ever since. The consequences of Moore's laws are profound. The cost of chips remained virtual and unchanged during third period of rapid growth in density. The second one, because logic and memory elements are placed closer together on more densely packed chip, the electrical path length is shortened, increasing operation speed. The computer becomes smaller, making it more convenient to place in a variety of environments. There is reduction in power requirement. The interconnection on the integrated circuit are more reliable than solder connection. The question number 8. List and explain the key characteristic of a computer family. The first one is similar or identical instruction set. To understand it more easily, this computer program on the computer can also be run in another computer. The program or instruction set are pretty much the same between same computer family. Similarity or identical operating system. The same basic operating system is available for all family members. Increasing speed. The speed is executing for running program is getting faster and as the higher the computer family is. Number of input-output ports. Number of ports will increase from lower to higher family members. Same with increasing memory size and increasing cost. Question number 9. What is the key distinguishing feature of microprocessor? In a microprocessor, all of the components of the CPU are on a single chip. The key distinguishing are clock speed, bus width, number of transistors, microns, addressable memory, and virtual memory. Okay, after answering 9 of the review questions before, now I'm going to solve the problem that also given by my lecturer from the university. Here are the questions. We can look at the contents and address of the IAS computer shown below. Address, we have 08A, 08B, and 08C, and we have content here, here, and here. Okay, so first we need to show the assembly language code for the program, starting at this address 08A. So for this we need an IAS instruction set and also the table for hexadecimal to binary. Why, we're going to explain later. So contents, this one are contents divided into up to 5-bit instructions. So here are first 5-bit and here are the second 5-bit. We change it into like H and RH. LH instruction, we have 010 FA, 010 FA. So we have opcode for the 01, the first two numbers, and then the address will be the third last 0FA. For the right hex instruction, we're going to have 210FB, 210FB, 210FB. The opcode is 21 or 21, and the address is 0FB. Since this is hexadecimal, so we need to convert the number into binary. The opcode are still in hexadecimal, so we need to convert the numbers into binary. How do we convert it? We look at the table. So we have, if we have 0 here, we change it into 40 in the binary. And if we have 1, we change it to here binary. For example, we have the LH instruction. For this one, we have 01 for the hexadecimal, then we convert it into 000, and then for 1 we convert it into 0001. Then we look at this table, instruction IAS table. Then we have 000 and then 0001 here for load MX, so we can make it same with load MX. The MX, we can reverse the memory to the address location 0FA, so we change it into load MOFA. The X we change to the location or the address OFA. Do the same thing with the right hex instruction, 2, 1, and then we find the hexadecimal and then we do the binary. So we have 0010 for the 2, and then 0001 for the 1. Then we find the instruction. We have store MX here. We change it into store MX, then we reverse the X into the address, which is 0FB. Then we change it into store MOFB. Do the same instruction until you get all the answer, the result. For 0xA address, we have this. For 0xB, we have this. And for 0xC, we have this. Second question is going to be explain what this program does. So this program is to store the absolute value of content at memory location 0FA into memory location 0FB. Okay, I think that's all for today's explanation for the questions and problems. Thank you all for listening. I'm going to end this session.